Okay, many amateur radios have a meter that indicates numerical strength and the signal being received. Okay, this is a separate issue. And these radios won't have it. And these radios tend to have it, but not really. They do a little bit. But the big radios we have in our homes have a nice big meter on them. And when I'm talking to somebody and I've got a signal that's coming into my radio, the meter will tell me how strong that signal is. If it's weak, the meter's down here. If it's nice and strong, the meter's up here. Okay? So that's that. These are typically the HF radios that we have in our houses. Okay? The mobile radios will have a little display here that will just give us a little bar, just a little signal bar like on your cell phone, but they don't give you the numbers. Okay. More miscellaneous. In today's digital environment, when several semiconductors and other components are combined into one package, that's called an integrated circuit. That's a lot of what we have today. So on this little black thing here, right here, we have an integrated circuit. Right? Now there could be, dozens and dozens of transistors in here. This is the whole circuit with all these little leads on the side. So there's an IC. Okay? Our HTs and mobile radios typically run off DC today. Okay, we went that. Let's go past that. The transformer, okay, we're talking about the power supplies again, so let's get back to that. Since we want to run our mobile radios from our house, we buy a power supply that takes in 120 volts and puts out 12 volts. Okay. We simply plug this into the wall. And then the transformer inside here is what changes the 120 volts to the lower voltage that we need before it's converted to DC. That's what was on the previous chart. I should move this question back the other way. In both cases, the regulatory circuit is what controls the output voltage of the power supplies and keeps it stable. So remember, we had the transformer that changed the voltage down, we had the diodes that rectified it, and then we had another circuit you didn't see that keeps that exactly at 12 volts and doesn't let it change. Just memorize some of that. Okay, this one's a little bit of memorizing again. It's about the term decibels. And decibels typically has something to do with something changing, like power changing. Here's the magic one. Well, when someone says there was no change and it was 0 decibels, decibels is abbreviated dB. There's two magic ones to remember. First one is 3. Every time something increases by 3 decibels, it doubles. That's it. If it increases by 6 decibels, let's see, the first 3 it doubled. If it went up 3 dB more, that doubled. Okay? So 6 dB is 4 times. That's how you remember that one. What if I go from add 3 more? Oh, then that doubled. You get it? The only one you have to remember is 3. 3 is double. Okay? Or it's half. If someone says it went down by 3, oh, it went down by a factor of a half. Okay? So you don't have to memorize that. So memorize the 3, that's double. Then if it goes to 6, that's 3 more, double that. Goes to 9, it's 3 more, double that. There's only one more you have to remember. 10 is 10. Every time something changes by 10 dB, it increases by a factor of 10. That's all you got to remember. I think we already covered this one. LED stands for light emitting diodes. LEDs are commonly used as a visual indicator, a little indicator that something's on. So there might be a little light. There could have been a little light on here. It's on the bottom. Okay, that says it's on. Well, what is it that's showing us the light? It's not a lamp. It's an LED. Okay. Displays on a handheld are typically LED displays. That will display there. It's an LED kind of display. They take very little power, and that's one reason why they're used for displays either here or on cell phones. They take very little power and not going to run your battery down very fast. Okay? The best type, okay, now we're going to switch gears. We work on electronic stuff. Sometimes you have to solder some things together. Okay? So here's a roll of solder. It's kind of bendable if you've never seen it. And what is it? Well, it's kind of a leadish material, but it's got something in the middle. What it's got in the middle, it's called rosin core. Okay? So the best type of solder for radio and electronic use is rosin core. Just memorize that. So this little flexible, looks like lead, it's got this rosin core inside. So when I heat something up to solder it goes and it just flows. This thing just turns into a little flow and just flows, and it solders things together. Now, sometimes we have what's called a cold solder joint, which is not good. So if you have a cold solder joint, then it will appear grainy and have a dull surface. Just memorize that. Let's not get into that. Let's not get into that. Okay, this is just a bunch of things that you guys should all get, but keep in mind, look at this 1, 2, 3, 4, 5, 6, 8, 9. Only one of these is going to be on your test, okay? So if I have 1.5 amps, I have 1,500 milliamps, right? This is all about prefixes now. Okay, 1.5 million hertz is 1,500 kilohertz, yeah? 1 kilovolt is 1,000 volts, yeah? A microvolt is 1 divided by a million of a volt, 1 millionth of a volt. 500 milliwatts is a half of a watt. 3 amperes is 3,000 milliamperes. 3.52 megahertz would be 3525 kilohertz. And 1 microfarad is 1 million picofarad. So some of these are pretty obvious. Some of you might want to memorize it. Only one can be on your test. Wow. That's 17. So we have time left. What I'm going to try to do, we're not going to go to the next one because that one takes a lot of props. We're going to skip right to number 20. I'm going to see how much of number 20 I can get through. And then just tell me when to stop. That way next week we'll have maybe 2.5 to go through, but one of them's pretty long and it's got a lot of props. Okay, so this is called safety first. And there's some stuff here that won't make any difference to you, but let's just see. And just tell me when we have to stop. Okay, electrical safety issues. So here we are again with our little plug, okay, and our switch and our fuse and the transformer. Okay, fine. So what's this all about? Well, in the old days, or actually not in the old days, in some devices, we have two things on the connector, right, on the plug. Two. But some have 3. Why do they have 3? Oh, here's why. If you have 2, one of these one's the hot one, one's the common one. Let's say that this is not a power supply. Let's say it's a refrigerator. Here it is. And all of a sudden, the hot wire accidentally inside the refrigerator touches the case of the refrigerator. Oh, and I happen to walk to the refrigerator, I grab it, but I happen to be turning on the cold water faucet in my sink. I'm going to get killed right there. Okay? So what they did in the world of electrical stuff, they said, let's put in one more wire. This wire here comes from the side of your house, and it's a ground wire. When it comes into this utility, called a refrigerator, it gets connected right to the chassis of the refrigerator. So if the hot wire ever accidentally touches the chassis of the refrigerator, it blows the fuse, and you never get killed. That's what the green wire is about. So this is a plastic case. That's why it doesn't need a third wire. But if I had something that was metal, this is plastic. If I had something that was metal like a refrigerator, trust me, it would have the 3 wire ground. That's what the green wire is all about. Okay. Okay. So the green wire and the 3 wire 2-port is a safety ground. The fuse obviously is to interrupt power in case there's an overload, right? It blows the fuse, right? And a fuse should be built into if you want to build something in, if you want to, a fuse should be built into a home-built equipment that's powered by 120 volts. So what it's saying is if you want to build something that's going to be powered by 120 volts, make sure you put a fuse circuit in. That's all it's saying. Health and safety issues. This is a little tricky. It says 30 volts can be dangerous to the human body. Okay, keep that in mind. But then it says 100 milliamperes, or 1/10 of an amp, to the human body can be fatal, and the heart is the most susceptible organ. The problem here, or the issue here, is they don't tell you. You have to have both of these. Okay, you have to have them both. If you folks have ever heard of a Van de Graaff machine, that's a big ball that puts millions of volts out. And what they like to do is they like to put a lady inside here, and she puts her hands on the Van de Graaff machine, and they turn it on, 1 million volts, and her hair stands on end. How come she doesn't die? 1 million volts is more than 30. Because that machine doesn't put out any current. There's no current. Okay? So the issue here is once you get over 30 volts, and once you have the ability to put out more than this amount of amps, then you can be fatal. Okay? So current flowing through the body causes health hazards, yep, and it does it by heating the tissues up, yep, by disrupting electrical functions of the cells, okay, and by causing involuntary muscle contractions. Okay, memorize that. This sounds like one of those A, B, C, D, all of the above kind of things. Electrical shock protection at your station. Now that means, not this station, not the one in my car, the one in my house. This is really talking about the one in the house now. I got a radio in the house, HamRadio operation. It says it should have a 3-wire. It should have a 3-wire connector. Okay. It should connect all the AC radio equipment to a common ground. What does that mean? You can take these equipment that I have in the house and I can scrap them all together. And then I hook them to a common ground. That way, when you accidentally touch one, you don't get zapped. And if one has a short inside, it ain't going to shock you. So this is public ground. Okay? And use the circuit protected by ground fault interrupt. Your body's little ground fault interrupt units, you plug them in and plug your thing that, and they're suggesting that in a house that's what you want to use. Okay? Let's forget about this. We don't need to know about that. It says I got a radio and I got a 5-amp fuse. So let's say I had my car radio and I got some 5-amp fuses. And all of a sudden it blew. For some reason it blew. And all I have left in my car in the glove compartment was some little 20 amperes. I said, well, I'll put a 20 amper in until I get home. Well, it says, don't do that. It says replacing a 5 amp with a 20 amp could result in excessive current that could cause a fire. So what it's saying is this. Maybe there was a circuit inside that was starting to heat up, and that's what blew the fuse. Well, now if you put a 20 amp fuse in, that circuit can heat up more and more and more and more because it'll let 4 times more current go through it. So it says that's not a good idea. If you turn off or disconnect the power supply, you might receive electrical shocks from stored charges in the capacitor. So what it's saying is this. I got a big power supply at home, not a little small, big one. And I turn it off, I open up the case, and I want to go inside and start working on something. Well, the problem is there's huge capacitors inside, and they hold the charge for several seconds. And some of these might have 600 or 700 volts or 1,000 volts on it. So the last thing I want to do is stick my hand in and start working on it. And these things are still charged. That's what it's talking about here. Capacitors have stored charges. You won't have to worry about that. What we're going to do. Let me know when to stop.
2 minutes.
Okay. Battery emergency and safety issues. If the commercial power is out, that means the power coming out of your wall. Okay. One way to recharge a lead acid battery is to connect the battery to the car battery and run the engine. So what it's saying is, here's a simple way of saying that. The AC power goes out, it's an emergency. My battery's dead. How do I charge it? Oh, remember what I told you? You buy the battery charger unit, hook it in, take it to your car, plug it into that cigarette lighter, and you recharge. That's what that question's saying. Hazards presented by the conventional 12-volt storage battery. What they're saying is, let's say you have a 12-volt battery, but you've got to clear inside the building. You say, well, I'll just put a 12-volt battery here. I'll run my radio directly off it, but I'll have the battery right here inside the building. Well, some of those batteries emit ozone, which can be harmful. Okay? Shock hazards due to high voltages. Well, I disagree because it's a 12-volt battery and you need at least 30 volts before you can get a real shock off it. You're not going to get a shock off a 12-volt battery, but that's what they're trying to tell you. Excessive gas can be collected if not properly vented, because some of those batteries in our cars, they vent. And if you don't vent that gas outside, it's going to be here in your room, so that's the problem. If a storage battery like a 12-volt car battery is charged or discharged too quickly, it can overheat and give off dangerous gases. So let me just give you one thing. Say I took a metal screwdriver and put it across the terminals on a 12-volt battery. That battery will probably explode because it's putting out too much current right now. Okay? That's part of the problem. Okay? It could overheat and give off dangerous gases. I think that's probably as far as we need to go. So next week what we'll do is...
Next week, tomorrow.
Tomorrow, yeah, please. We'll pick up with the rest of this and then we'll do the other 2 sections.